David Spieth here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Parallel lines. They have so much in common, it's a shame they never meet. So you guessed it, today's topic is parallel lines and perpendicular lines. We're going to start with parallel lines first. So parallel lines never cross, they never meet. They have the same gradient or slope, and that makes sense because if they had different slopes, eventually they would cross. So they have to have the same slope. So I'm going to show you a little notation along with the diagram right here in a sec. Okay, here's 2 lines, and I've described them by showing you 2 points that are on each line. So we could call this one line AB and this one line CD. Now we can write down notation that would tell us that this one's parallel to that one, and it would look like this. Okay? And that just means AB is parallel to CD. And that symbol is pretty easy to remember because it's 2 parallel lines right there. Let's look at perpendicular lines. The definition is that they cross at right angles or at 90-degree angles. So they cross exactly at 90. And so we often say one line is perpendicular to another. Okay, I added 2 perpendicular lines there, and there's one special symbol we throw on this diagram to indicate that they're perpendicular. Think about that for a minute. Do you know what it is? If you thought about this little box, you're right. So that tells us that line PQ is perpendicular to line RS. So now we have some notation. It's pretty simple. PQ is perpendicular to RS. And this one also kind of makes sense because we're drawing one line with a perpendicular right to it there. So that's how we use notation. Here's our definition of perpendicular lines. Now perpendicular lines have a special relationship using their slopes. So what I've done here is given you that definition. They're related by the negative reciprocal. So that means that the 2 slopes together are related by the negative reciprocal. And there's a bunch of things we can do with that. First off, let's just review what that actually means, negative reciprocal. So I'm going to do that with an example. For 3/4, the negative reciprocal is minus 4/3. Now you might be remembering from prior classes that the reciprocal is just if you take a fraction and you turn it over. So 3/4, the reciprocal of 3/4 is 4/3. We just flip the fraction. But since this is the negative reciprocal, we flip it and add a negative sign. Or better yet, we flip it and change the sign. So this one's positive, so we flipped it, 4/3, and since that's positive, we make this one negative. So go ahead and pause the video and see if you can come up with a negative reciprocal for negative 5/3. Okay, now we flip the fraction, so that's now 3/5, and since it's negative now, we're going to change the sign and make it positive there. Okay, another way to think about that is if we make the negative reciprocal of this one, we flip it, and then we have 2 negatives. So we have negative 5/3, so that's why that goes to positive. Now there's a really cool way to check if you've got your negative reciprocals right. If you multiply them 2 together, it should end up being -1. So let's test that idea. Here is a slope, a fraction. The negative reciprocal is going to be flip the fraction and change the sign. So that's going to be 7/3 minus, okay? Now if this idea is right, if I multiply these 2 together, I should get -1. So let's test that. 3/7 times -7/3. Now when you have 2 fractions multiplied, you just multiply across the top and multiply across the bottom. So I'm going to get minus 21/21, and that is -1. So if you're needing to check or do something else with a problem that involves negative reciprocals, you should remember this relationship, that when you multiply them both together, you should get -1. So let's do a little problem. And I bet you're wondering why this thing was all over there this whole time and I haven't referred to it. So here's the moment. Okay, so I have 2 lines, NN and OP, And you can tell by my notation right there, I'm telling you that they're perpendicular to each other. There's also another clue. This little square box here tells you that these two lines are perpendicular. Okay? So here's the question. If the gradient of MN is 10 over 3, pretty steep slope, what is the gradient of OP? Now if you remember from the previous lesson, pause the video right now and see if you can do that. Okay, let's see how you did. You flip the fraction and change the sign. So this would be minus 3 over 10. Okay, pretty straightforward. Now let's test it. Let's multiply these two together and see if we get negative 1. 10 over 3 times negative 3 over 10 is going to be negative 30 over positive 30, which is indeed negative 1. So we did that right. Okay, let's use this concept of slopes and perpendicular lines to say something about a triangle. So the type of problem you might get would look like this one. Triangle ABC has points A, B, and C. And you can see I've given you the coordinate points for each of those 3 points. Now the instruction here is use gradients to show that triangle ABC is a right triangle. Now, you might be thinking you could use the distance formula and the Pythagorean theorem to do this, and you'd be right. And some of the exercises that you'll be doing for this lesson will involve some of those other theorems that we've covered in this chapter. But right now I'm going to stay focused on gradient. So, to show that ABC is a right triangle, we need to have one 90-degree angle in that triangle. That's the definition of a right triangle. So to use gradient, we need to find the slopes of all 3 sides and look and see if the slope of one side is related to another one by the negative reciprocal. And we can do that. We have all the tools. Now you have to remember, our slope formula here is y2 minus y1 over x2 minus x1. So we're going to use that extensively, like 3 times. So let's go ahead. We've got 3 sides to this right triangle. AB is one side, or to this triangle we don't know yet. AB is one side, BC is the other side, and then AC is the third side. So I've got 3 gradients to calculate. Let's try AB first. Okay. Remember, y2 minus y1 over x2 minus x1. So y2, 2, minus y1, 7, over x2, 3, minus x1, which is 2. So 2 minus 7 is negative 5. 3 minus 2 is 1. So this slope is negative 5. So that's the AB side of the triangle. Now let's do BC. So now we're doing these 2 points. y2 is 3 minus y1, which is 2, over x2, which is 8, minus x1, which is 3. So this one's going to give us 3 minus 2 is 1, 8 minus 3 is 5. Now you might already be seeing the answer to this problem, but I'd like to do one more slope calculation to be super thorough. So let's do AC. y2 is 3 minus y1, which is 7, over x2, which would be 8, minus x1, which is 2. 3 minus 7 is negative 4, and 8 minus 2 is 6. So minus 4, 6, which reduces down to minus 2/3. Okay, so I have 3 slopes. Negative 5, 1/5, and 2/3. So now look at those 3 slopes and see if any 2 of those are related by the negative reciprocal. And if you haven't got it yet, I'll give you a hint. Yeah, it's there. 2 of those slopes are related by the negative reciprocal. Okay, check it out. It might be hard to see, but it's these 2. Negative 5 is the same as negative 5 over 1. So if we take this fraction and flip it, then change the sign, we're going to get positive 1/5, which indeed is what we have for BC. So the answer is yes. This is a right triangle. Now we didn't have to graph it, we didn't have to use Pythagorean theorem, we didn't have to do any of that stuff. All we did is we found three slopes and we looked for the negative reciprocal. So a word about some of the problems you're going to see in the exercises. They can get complicated, and they're going to dig back to previous lessons. So you're still going to need to know your midpoint formula and your distance formula. You're going to need to be able to do that, and of course, the slope formula, which we used here. So all of the stuff we've been working so far in the coordinate geometry chapter is sort of coming together a little bit in this lesson on parallel and perpendicular lines. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.